Welcome to this video where you will learn how to easily create a project to implement the ESIstream serial interface for the ADC EV12AQ600 or 605. We estimate on average that you will gain 5 weeks of development time if you implement this ESIstream serial interface following this tutorial. So, using the AQ600 FMC board connected to a FPGA carrier board, you will learn how to program the FPGA and how to receive sample using Python script, Vivado Hardware Manager, and Vivado Integrated Logic Analyzer. In this way, you can test that the ESIstream serial interface integration is working properly. Here, you can see all the supported FPGA carrier boards. We developed a dedicated VHDL design example for each of them to facilitate the use of this ADC. All the links to download the design examples are available in the description of this video. Now, I would like to focus on one of these FPGA carrier boards. The AQ600 is space qualified, and extensive testing has confirmed the ESIstream serial interface radiation tolerant. So, this ADC is an ideal companion to the space-grade radiation-tolerant FPGA XQR KU105. A link to the heavy ion report is also available in the description of this video. For industrial systems, we can deliver different design examples. Here you can see two of them, one for the Kintex UltraScale FPGA and one for Virtex 7 FPGA. Now I'm going to show you all the steps to start receiving samples. Here you can see an overview of a demo, but we will look at each step one by one. So let's start. First, download the package for the KCU105. The package contains all VHDL and constraint files, Graphical script to generate the project, and Python script to create a graphical user interface. In your web browser, type www.ESIstream.com, click on Package, then on Start your ESIstream project using an existing package. Scroll down until you find the right package and click on Download button. Then unzip the package in your working directory. Now we have downloaded the package, we can create the FPGA project using Vivado. This project uses Vivado 2019.1. Open Vivado. Click on Tools, Run Tickle Script, and look for available tickle script. In the package, select the right Vivado project and select one of the tickle scripts. To determine which script to use, please check the ESIstream.com FAQ webpage. In this tutorial, we have selected the 64-bit tickle script. Then click OK. Wait for the end of processing. It can take a few minutes to generate the project. Once the processing is complete, the project closes. Click on the Recent Project view to open it. You can now generate the FPGA bitstream. It takes approximately half an hour to complete. Now we have generated the bitstream, we are ready to load it in the FPGA. Before powering on the FPGA board, check that all power supply switches are on off position, then connect power cables, UART cable, and JTAG cable. Now you can switch on the FPGA board. At this stage, you can program the FPGA. Click on Open Hardware Manager, then Open Target, Auto-Connect. The FPGA target appears. Right-click on the FPGA reference and click on Program Device and Program. Now we have programmed the FPGA, we can power on the AQ600 FMC board. The hardware setup is now complete. We can launch the graphical user interface using a Python script. Open a command window in the package folder Python API and type python GUI.py com plus the ID of the compare. You can find the ID of the compare in the device manager. For this demo, I configure the ADC in one-channel mode. This is the default configuration. I also configured the 6.4 GHz ADC clock frequency. This is the maximum frequency. The ADC embeds the cool features to check that the ESIstream serial link is working properly. We call this the ramp test mode. This mode allows you to send a known pattern to check in the FPGA that there are no communication errors. So, let's look at how all of that works. First, program the PLL that generates the ADC clock. Then, configure the ADC with selected mode and synchronize the serial link. At this stage, the communication has started. Make sure that LED 3 and 4 remains off. If they switch on, it indicates a communication error. Going back to the Vivado Hardware Manager, we can now start to acquire sample data using Vivado and save it in a CSV file. Close and reopen the Hardware Manager to refresh the Logic Analyzer. Launch an acquisition and export the CSV file in the same directory than the Python script. You can now display the data both in time and frequency domains. We can check here that the test ramp pattern is displayed correctly. This brings us to the end of this video. You have learned how to get started with ESIstream and the EV12AQ600 ADC. And so you can see how it will help you to gain precious time in your development. Plus, the ESIstream license is free of charge and open source, so you can modify them as necessary. All the useful links are available in the description of this video. And if you need any support or if you have questions, please contact us using the Teledyne hotline email address. Thank you for watching.